Okay, so, is this 146? Yes, that's 146, it's Friday. So this is video 146, it is Friday. We're doing PAINT5D stuff. We're on part 77, so let me go down to the bottom kind of title screen. We'll figure out how to quantize our workloads into more granular units in the future. So let's give a review of what we have and where we're going. Because I don't really feel like doing much code right now, but I do want to... what is it, 146? Hold on. Let me update what stream number we're on. 146. So, right, we got this editor, we can put a pattern in it, and we can see that pattern. And then we can also inspect the memory for the PAINT5D system. So this is like a memory inspector that the colored pixels you're seeing, well, the 4 colored pixels here, the 4 colored pixels here, the 4 colored pixels here, and the 4 colored pixels here, they're just debug variables. And then this big strip of data you see here is actual variables in action in the editor. This green pixel you see here is storing the auto tile index. And these colors you're seeing right now are not true to life. They're not they're not the actual values. Like well, these pixels are over here. Okay, if the pixel is completely black and the alpha channel is non-zero, then we do like a tinting to those pixels so you can see them. So when we're storing variables, most of the variables we're storing are never going to overflow outside of the alpha channel, right? They're going to be 32 bits. And since we're packing stuff into pixels, we have... oh, did I have that right? Oh, okay. So 32 bits equals 1 pixel. And usually, a lot of values aren't going to go over 15. The auto tile set index, for example, is only 0 to 15, so the bits never flow outside the alpha channel, so unless we use some type of coloring scheme, we can't actually see those bits. So let me show you, let me restart the engine really quick to show you what I mean. So, because there's some craziness. But it's not obvious unless we start up the engine before we go into the first editor. Before we go into the PAINT5D editor, if we take a look at the memory inspector, so I'm going to press key number 0, and you can see, like, whoa, a whole bunch of, like, crazy stuff, right? And so this is, it's obviously not all black anymore, right? And the reason we're not seeing all black anymore is because anything that I want to look at where the RGB and RGB are black, but then the alpha has some type of non-zero value in it. That's what we're looking at here. We're looking at a whole bunch of things where RGB are black, and then alpha is non-zero. And if we just took the raw pixel color value of those kind of bits, we would just see black, right? So I had to give a special palette to pixels that fit that criteria so I could inspect the memory and be like, that's interesting, right? And so this is really interesting. It looks to me like it's just junk data. It's either junk data that just was in there from initialization, or it's leaving the state of that memory dirty after running tests on it. I don't know. I just don't think it... I'm skeptical that it should be this, though. Because these are a whole bunch of variables I don't use. But anyways, so if we go here, though, and then we go into the PAINT5D system, right? So here's the PAINT5D system, and we go back to the memory. Still nothing. Okay, oh wait, but then we can see that something up here has changed. The variables that are actually being used have been set. Right up here, you can see them. I could probably confirm that, so I could probably go here, and I could go up to the highest auto tile set, and if I go back here, I can confirm this little green pixel here, right? There's a little green pixel here. If I go back, and I go down through my auto tile sets, so I'm going to go down. You can't see anything, it's just white, but trust me, I'm going down through the auto tile sets. And now we look at this, you see that green pixel, it's gone. Now, if you want some more confirmation, right, we can go back here, we can load a pattern, and then when we go through the auto tile sets, we can actually see some data. So now we're at the highest auto tile set. If you look at the memory inspector, hey, here's that green pixel up there, right? That green pixel is saying, hey, when I am exactly 15 on the alpha channel and all my other channels are black, then make me green, right? Just a way so that I could inspect the memory and find this data point kind of sticking out like a sore thumb. So a very kind of hackish debugging kind of system here. But okay, let's go over here now and let's set the debug variables. So let's set some debug variables on the corners of this texture so that we can further assess what's going on here. So let's go over here. I'm going to press U, and that's going to give me some debug data that's going to set into the texture. And so all the original variables that I'm actually using are still here, up here, these variables. But now I have these debug variables in the corner. And those debug variables are just there to block out the memory region where all the variables for the PAINT5D system are going, right? So this is a 32 by 32 pixel chunk where we're storing PAINT5D variables. But it's on a larger texture. So we're kind of zoomed in onto this texture, and we're just trying to render it so that we can visually inspect it, right? So with this ability to visually inspect, we can now better kind of figure out why our texture pushes aren't working. So that's kind of the goal. One of the things I wanted to do was I want to... I'm doing this very hackish thing where I'm not using the OpenGL headers, and I'm just kind of hard coding different constants, which is really could make for some very brittle code. And I would like to I don't want all that cruft from OpenGL in my system. So I was thinking about, well, what's a compromise where I could avoid the cruft in how I'm setting things up, but then also get some type of advantage here without having any brittle code. I was thinking what we could do is OpenGL headers, right? And so let's just go find the OpenGL headers, try to find the newest OpenGL headers. And I'm thinking of including those at the very end, like after the whole program has included all its files. Then we could include the OpenGL headers, and we could just use the OpenGL headers to cross-check our like mini OpenGL headers. Right? We have these mini OpenGL headers where we've just taken the values that we're concerned about, and we could do that, and then we wouldn't have to worry about OpenGL accidentally colliding with any of our code. I think it would be a good idea. So, but where to get GL header? So yeah, where do we get these things, right? This is glue, the gl.h. Okay. If you want to use OpenGL 3x or OpenGL 4x functionality without the functionality which removed in... Um... Okay. So... really wish it... So I guess we'll save these headers somewhere. I don't know if they're the exact things I need, but, God, I hate people attaching URLs. Copy link address, Chronos headers. So Chronos. And it's Chronos headers. Chronos header. Okay, so let's go download those, put them somewhere. I'm just gonna put them in my delete me folder for now. Desktop, delete me, Chronos headers.zip. Okay, and then once they're open, we can show in folder, extract them. Chronos. There we go. Extract all. Let's take a look in there and see what we got. Are they up to date? That's the other thing I want to know. Are these up to date? CL 1.2, CL 2.0, EGL, GL. So these are kind of like all the headers, huh? KHR, VG, I don't know what VG is. Is there Vulkan, like VK? Or is yeah, I thought Vulkan was a whatever, this might be old stuff, but, so GL. GL core, GL text. Got ya. So we could take this GL core, copy it, and we could use it in its dependencies. Error checking. readme.txt. Just make a little note here that, you know, these dependencies are not meant to be included at the beginning of the project. They are used to cross-check my mini headers against the official headers and make sure they are correct. Right, so that's what we're going to use it for. And I'm kind of tired. I don't really want to do anything. I just wanted to get a little bit of something done. But I gotta say, what is it, the 10-minute rule? There's a thing called the 10-minute rule where it's like, hey, just, you know, hey, do some stuff for, like, you know, 10 minutes, and then, right? Because the hardest part is getting started. Well, we've been doing this for 15 minutes, and I still don't feel like doing it. So let's go open up GL Core for a second and inspect that, see what's in there. And it's a lot of nonsense. GL this, GL that. Right, here's the numbers I care about. These numbers, right? So cut and paste from here. And some of these numbers I like want to cross-check. So full file path to clipboard. Let's go add this into our build system here. So file, open, and go open up, maybe not this, but in lib, there's libchan, right? Libchan. Top. And this isn't really what this is for, though. Where's libchan included for a second? Libchan. So here's our main C11 file. Let's see kind of how that all goes together, right? So we have this stuff, and we include, like, a libchan, and then here's main, and then f macro is bot. So what I'm thinking is, you know, we do something like include lib slash so we want to check for errors. I don't know what to call it. And I don't know what the extension is going to be called. I'm just going to call it, I'm just going to do this. I don't care. That's a weird name, but that way there's not a top and bottom file. It's just check error. It's just at the bottom. Or so usually when I name something top and bottom, that means that there's a file called top and there's a file called bottom, right? They're paired together. Bottom dot only, right? So it's a bottom file, but there's only bottom. Bot, only bot. I don't know. Or we can just give it a convention like this, and I don't know. Let's just call it this because I'm having fun. So check error. Check for errors. Right, and then save this as. I'm just going to say this is like check for errors, and then we're going to include in lib, we're going to call it, you know, check for error, ERRORCH, that's 7 letters, dot 123 underscore underscore, right? 123 dot underscore. Okay, save that. And then here we're gonna say, you know, include dot slash dep slash. Let's go figure out where that's coming from. So in dep, we have error checking, and then this thing, right? And the idea is that we're not going to use this header for setting stuff up. We're just going to use it for cross-checking ourselves to make sure we haven't made any mistakes. So let's give that a shot. And okay. So things still work, so that's cool. Now the reason I want this, let's close some of this stuff. Close that. So I want some type of code that I can run. So before enter main error checks. So before we enter main error checks, right? So that's kind of what I want this to be. At least I think that's what I want it to be. I'm not sure. And we'll call it, you know, so I just want to cross-check some of the headers I included. Like, I have my own mini headers. I'd like to cross-check them against the actual header. So, so we got the project namespace, we got the sub namespace, and we got what we're gonna do. And then where are we gonna call that from? So let's go open up this and say, well, here's main, and here's the function. And we got all these kind of things, input handler. So at the very bottom, we probably have the main entry point function, right? So, int main is right here. So before it enters any kind of loops or whatnot, we could do some checks. So we could run this. So I'm expecting it to be simple enough where I can just run it from here. And that should be good enough. Because all the library struct should be kind of statically initialized. Or initializing kind of a, I don't know if array is the resource what is it? Resource allocation is initialization. So when you use an initializer list, I don't know if that counts as array. But all of my header libraries should be kind of initialized in that manner, so that if I want to cross-check them, I can cross-check them right here, and we're actually going to be good to go, right? So there are some values that I want to check, but before we do that, let's close this and let's give this a run. And we're going to see if we can. We just want to make sure we don't make any stupid syntax errors. AAC 2020 CH error cross-check headers implicit declaration. What orders is this being included in? Is this not being included? Oh, because this one gets included at the very last, so therefore Oh, I see. Okay, well, if we're gonna do this, then it has to be... The order in which we have included these files is not gonna work out here, right? So, if we want main to do the cross-checking, because we're not doing kind of a static kind of thing, then we're gonna have to put this above main, right? Okay. Sure. And this is why I would kind of want to put it in libchan, just because... You know what? Let's just put it in... I don't like how we're kind of like cluttering this up. Let's take this and let's just throw it in libchan, which is kind of like maybe a bad place to put it, but that's where we're going to put it for now. We're just going to hide it in libchan. So libchan top, the top file, right? We want to include it before we're including main and whatnot. And we'll include it down here and just say misc stuff I hid here. So basically, I don't want to overload somebody looking at the project with like a whole bunch of stuff, so I am going to just hide it down here because it's one of those little details that it's not going to help you understand the project any better. It's just going to be one of those distractions, right? So I don't want any distractions in my main file here. I want this to be a nice little summary of what's going on, and if we try to add too much stuff in this top level code, things are going to get confusing as far as I'm concerned. And it's not really top-level code because it's not called from the top level, right? It's called by the main, so it's not top-level anyways. So, we can make a note of this. You know, it's 1:46, and the time is 28:23. Keep up with the conspiracies. Tuck this away to avoid cognitive overload to new users of the code base. Right, so anything in here really is for this purpose. Right, the idea is tucked away to avoid cognitive overload to new users of code base, right? That's all we're doing here. Okay, so we still want to make sure it runs. And then we'll kind of like add like a little check on it, right? We'll cross-check our GL bindings against oh yeah, that's right. So now it's in a different, the relative file path is different, right? So it's in libchan, so technically we don't even have to go lib, we gotta just go / right? So we can get rid of that. My bad. So hard linking stuff like this, or it's not really a hard link. It's still a relative link, but it's not as flexible as like the less than, greater than brackets you can use. But then using those kind of brackets with an include, you have to adjust the linker settings. So it's like, I would rather not. So taking a look at this, well, I'm seeing that all of a sudden my keyboard doesn't work. I don't think that would be the case. I don't think that, you know, it's just like, oh god, I think it's, For some odd reason, sometimes my shortcuts, my keyboard shortcuts interfere with the engine. I mean, most games, my AutoHotkey script interferes with the keyboard input for the game. Not just my engine, but any other engine. I don't know why. Something I do want to fix eventually, because I don't understand how it works for like it works for text editors and works for everything else except for like real-time interactive simulations. I have no clue why. Okay, so we have this, and now let's put it to use just a little bit, and we're just gonna cross-check some things, right? So we have like a GL constants thing, right? So let's go find our like texture pushing that's not working out for us very well. So TauSync has a texture push function in it that's killing us right now. Let's just search for 0x because it should be caps lock. Insert home, page up, delete, and page down. Caps lock is not there. Where the hell is the caps lock key? I never use the caps lock key. I don't even know where it is. Okay, there, found it. I like accidentally hit it once in a while, and then it drives me nuts when I'm trying to find it. Okay, so if we look for, you know, 0x, I know 0x is kind of a weird thing to look for, but I'm going to take a guess and think that maybe I can find what I'm looking for if I just look for some hex codes. Yeah, so this is actually what I'm looking for right here. Right, so we're doing like a subtext push here. And right now, we're not sure that these hard-coded constants are correct. So what I want to do is just say assert that I don't think it's called GL constants. What's it called? So I have like a const. Oh, it's called GL const. Okay, yeah. So define GL const, we'll just call it GLC for short, and then undef GLC here. And assert GL const dot unpack alignment equals GL unpack alignment. And I don't even know if these variables actually exist in the code at all, right? So I'm just taking some guesses here. And we actually want to put the macro first. We want to put the macro first, so make sure we don't accidentally do any assignments, right? If this equals turns into single equals, we don't want to have a whole bunch of trouble on our hands. So let's not do that. Okay, so I don't even know if that's going to work because I don't know what's in my GL constant. So let's go open up GL const for a second. And, you know, whatever's in here, that's just what we're going to go with. So, yeah, we have these kind of things here where everything's kind of, yeah, we got unpack alignment, right? So we have these kind of different things that we definitely need. And our first attempt to make a bindings library, we tried to like categorize these different constants and nest them into like a data structure based on like their usage. And oh boy, that was a bad idea. That was stupid. But yeah, the idea is that we just want like little libraries of only the constants that we actually use. So, like there's a lot of stuff in OpenGL, but I would like to just, when I'm looking at the code, I want to just be able to look at, you know, what I actually use, because I think it's going to be easier. It's like, hey, we did some stuff with texture. Well, you know, here's these things say texture, these things say texture, right? Whereas if we're looking at the entire GL core headers, right, there's more stuff that involves texture, right? So the idea is that we can find our way around the code base a lot better if we get rid of unnecessary variables. So if we're including an entire header with a whole bunch of things that we don't use, we have unnecessary problems. We have unnecessary variables in our problem, right? So like when math teachers give you a story problem and they give you like a whole bunch of unnecessary variables in the story problem that are just there to distract you, I think the same thing kind of happens when you include headers. So we're going to include the header, the GL core ARB, at the very end of our project, so it's not actually going to be useful for any of the code we're writing, and then we're just going to use it to cross-check the code we actually did write, right? So in this mini header thing, right, we have hard-coded these values here, and now we can cross-check them against the header, right? So we can have some less frail code, but still get the advantage of not having unnecessary variables in our story problem. So let's look at what's in TauSync, right? So let's take every one of these things. So row length, GL texture, GL texture 2D, right? We're going to take every single one of those, and if it doesn't exist, we're going to add it to the to our constants library, right? So we're just going to steal these. Right, we're going to steal all these values right here. And make sure that they're proper, right? Okay. So now that we have these, I'm going to assume that, you know, some of these aren't going to work. And also, we got rid of the GL on these, right? So we got rid of the GL on all these. Oops, my bad. Did that in the wrong order. So unpack alignment, unpack row length, GL something or other, GL texture 0. I wonder why things weren't lined up. GL texture 0, GL texture 2D, texture 2D, texture 0. Oh, this needs to be GL. So we got unpack alignment, we got unpack row length, we got texture 0, we got texture 2D, right? And some of these probably don't exist in our constants library, right? So if we look at our constants library, we have unpack alignment, but it doesn't look like we have unpack row length, right? That looks like we don't have it. So we're going to add that in. We're going to just add all these in, and then we're just going to get the F out of here. Texture 0 is already here, texture 2D is here. So unpack row length is the only thing we're missing. So we're just going to say, you know, U32 unpack row length, right? So unpack row length, just like that. We're going to make this, we're going to insert this and say, okay, well now, you know, now you are 10, and, you know, this is 11, this is 12, and this is 13, right? And then unpack row length is right beneath this. So let's go look for that right here. And so right down here, unpack row length is beneath that. So we can just go in here, go like that, paste that there, and then we got to figure out what this value is. And then we got to make our insertions. So 10, 11, 12, and 13. So we got 13 things now. We're actually just going to look on the web for what this value is. We're just going to look on the internet, right? We're doing an internet search and see if what we come up with the internet matches the headers we already downloaded, right? So GL core for URL, right? So let's just use GL core 4. Because that's like the newest thing, and see if there's any discrepancies between the newest and the oldest thing, right? So this is a hackish way to like do a diff, right? We're assuming that the GL core stuff doesn't change, but... Or maybe we won't, because I can't quickly find what it... So I'm just going to do GL core URL, and then... Oh, hold on. So let's just type GL core URL, and, you know, what's in my shortcuts, we're just going to use that, because I can't find what I'm looking for right away. And it's this unpack row length we're looking for. So let's go look for that in here. And we see, oh, unpack row length is this like 0CF2, right? So we'll copy that. And then we'll just paste it in there. Bam. There we go. We got that new value we needed, right? Okay. So now that we have this, the next thing is just to run the code and make sure that our runtime asserts don't fail, right? So let's do that. Let's go give this a swirl. I don't know, swirl doesn't... A whirl, yes, a whirl. I think that's the saying. Give it a whirl. And see if it doesn't fail at runtime when it calls that checking function before it enters the main loop. So before it enters the main loop, it's just going to do a little bit of, runtime checking to make sure that those values are correct, and nothing's crashing, so that looks good to me. Now, I mean, I'm kind of worried, so before we kind of say that we're done here, we're going to introduce an error, a pretty obvious error, right? And we're going to make sure that it crashes at runtime, right? So let's make sure that this isn't just a little fluke. Make sure that if we introduce some type of problem, we can actually see it happening, right? Okay, so we got the expression to get triggered. The next thing we want to do is, you know what? If we ship this and it fails at runtime, we're gonna be hating ourselves. So, goddamn, why is my bitrate? So we're just gonna we're going to just say AAC 2020 boilerplate. And it's NSSB paste, right? Okay. NSSB. No? That's not what it is? What the fuck? NSSB paste. NSSB paste. Okay, so obviously it's not NSSB paste, so what is it? AC 2020 boilerplate. Did I read that wrong? NSSBP. Okay, got it. So I'm gonna make a note there when you want NSSBP paste, not NSSB. Okay, so I made a thing to help me with the visual diff of that, because obviously I didn't look at that correctly. So over here, we're just going to say, NSSBP paste, boilerplate, BP for boilerplate. And we got all this stuff here for boilerplate. We don't need an init none function. It's not really that kind of code. And we're not really going to have a log function either. We just want a halting function, really. And it's just going to be like CHERROR, CHERROR, right, for check errors, halt. And then same thing over here, it's going to say CHERROR, and the message, a little error code, looks good to me. And over here, we're just going to define ERR as this halting macro, and then undef it down here. And instead of asserts, we're just going to say, if this is, not equal, if let's just say what about this? ERR, and then we can take this exactly verbatim. Right? Alright, I just don't want to take up too much room, right? So we could write it like this. Right, and so we got this, that. Okay. I like that. I like that kind of format. So let's take this and, let's first of all, let's make sure that we didn't make any syntax errors. Let's make sure that that actually gives us that feedback that we're looking for. I'm dropping 30% of my frames. Jesus. Yeah, no one's gonna want to watch my stream if I'm always dropping frames. Okay. Okay, cool. That works. So now that we know that kind of works for us, let's take it and go bam, bam, and bam, and then let's steal everything else. So unpack alignment, right? So unpack alignment, we're just going to take that, and we're going to put it over here, right? And then unpack row length, we're going to take that, and we're also just going to replace all this stuff, right? So we're going to, let's take all this stuff that says this thing here. We're going to say unpack row length, unpack row length. And then texture 0. We want GL texture 0 over here. And then GL texture 0. And then we want texture 2D. So texture 2D. And texture 2D. And then I would like to... I'm going to say that looks ugly. Like, I get the idea of, like, saving some vertical space, but oh boy, that just looks ugly to me. So that looks much better to me. It's still kind of weird, but that looks better to me in terms of, yeah, let's just do that. So let's put this over here, and then let's line it up with the error message. Yeah. So not equal. And then we're going to line it up with the error message, right? So we're going to line up that text with the error message. And we're going to get rid of some extra spaces. And then same thing over here, just because it looks better this way. Because I can see all the things that I need to see are kind of lined up right there for me to see, right? So I can see, oh, unpack alignment, right? Oh, there you are. You know, there you are. There you are. There you are, right? I can see them all lined up nicely. They're accounted for. Okay, so now that they're accounted for, the next thing is just, you know, make sure runtime asserts aren't getting triggered. Cool. So now what we can do is we can go into TauSync where we kind of hard-coded these things, and we can just make some asserts here, right? So we can, you know, assert that, we want to assert that these equal unpack alignment, right? So we're not, so the thing is we shouldn't be able to use this. We shouldn't be able to use the actual GL unpack because we included the GL header at the end, right? So if we try to compile like that, it should fail us. If it doesn't fail us, then I'm concerned. No such file directory. Yeah, undeclared. So GL unpack row length, it's undeclared, so we can't actually use this directly. Right, so we have to use, let's call it GC, right? So define GC AAC 2020 GL const, right? So we got GL bindings and we have GL constants. And it's 8:50. It's almost time for me to go because I gotta take drugs. So I'm gonna take my drugs and then just be done doing work. So this is being declared kind of locally right here. So let's go undef GL constants. I don't know if this is the best place to be putting this, but this is where we're putting it. So 2, 3, 4, 5, and 6. 7 of them. 7 of them, and oh boy. Our checksums don't match. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Oh, 3. That's the problem there. 3, 4, 5, 6, and 7. There's 7 here, and there's 7 here. So let's color code those. 1, 2, 3. 1, 2, 3, and purple. And 1, 2, 3, 1, 2, 3, and purple. Cyan. Okay, yeah. Okay, so just making sure that we have that correct. And now we can just add these asserts in here, right? So we got 1, 2, 3, 4 kind of hard-coded things here. So we're just going to hackishly kind of like make sure that they're all correct, right? We're just going to do a little check here, right? So this is our way of, like, maybe it's more work than it's worth, but this is what we did, right? So unpack, so URL is unpack row length, and then UA is unpack alignment. Unpack alignment, unpack row length. This one's texture 0 and texture 2D. Right? So you can make absolutely sure that those are the correct kind of shorthand things, right? But we're checking them at runtime. So that is kind of like ugly, but that's the way I'm gonna roll here. So as long as this still compiles, then I'm going to say that's good for now, right? So we're trying to, this is the texture push command that we're actually trying to figure out what's wrong with it. So first thing is cross-checking these magic numbers here and making absolutely sure they're correct, right? So so that's what we're doing. And things are still working. We can load a pattern in here, we can go through the pattern, we can see the tile set. Sprite for fork trade. I see. Clean fork, yes, okay. I was just about to stop. Okay, clean fork, got it. So yes. Okay, yeah, I'll stop the stream. I don't even think my bitrate sucks. I'm probably like breaking up right now. Okay, yeah. I'll be back some other day probably. Later.